NER, or named entity recognition, is a subtask in natural language processing. It focuses on extraction and identification of named entities in free text. So what is a named entity? A named entity can be anything. So it's a specific type of information we want to extract. So it can be things like names of people, names of organizations. It can be addresses, locations, dates, prices, amounts, whatever else. Or if we go a bit towards the healthcare side, named entities can be diseases, medications, symptoms, and anything else you can imagine that is a specific type of information we can find in free text. So
why is it called named entity recognition? Because it's such a strange name to me. The first time I came across the term, I thought they could have named this something a lot simpler and a lot more intuitive.
Yeah, I don't know. I mean, man, this was named sometimes in the 90s. This was part of the first time NER appeared in this field, or in field of NLP, was in these message understanding conferences, sometimes in the 90s, and NER was the name that was chosen for that, so named entity recognition.
Is there a better name you would choose? Let's say you invented NER right now. What would you call it?
Yeah, I don't know, because now I'm very biased, so now I'm like, it should be NER. That's just the standard name that should be used.
Computer picks out important words. Or words of interest. Words of interest identification. That's probably an even worse.
Yeah, that's name. More complicated than the NER part.
Okay, but so basically you're picking out the key terms in human language, essentially. So whether that's usually a noun, right, in kind of non-medical senses, but in medicine we can pick out diseases, drugs, other specific terminology, procedures, etc. Yeah.
No, exactly. I think the easiest is just to have a look at the example. So if we have a simple sentence like, Apple has yesterday released a new iPhone. If we now run a NER model on that sentence that is extracting company names, it should correctly extract the name Apple.
Or the fruit's apple.
Yeah, that one. So that's where the trick is. You could very easily say, yeah, exactly. Because if you now expand this use case a bit, and let's say you are looking for news articles that mention the company Apple. Now you collected your 1,000 news articles and you want to find the ones that have the mention of the company name. Your immediate approach can be, I'll just do a Control F. I'll do Control F, search for Apple, extract like that, or all articles that mention Apple. But this is where the problem happens. This is where your example with fruits comes in, because it can also be that some of these news articles mention apples as fruits, or mention Apple as a name of a building, or Apple as surname of a person, and everything else you can imagine that is not really the company. So you need a model that's a bit smarter, that's not simply looking for the word Apple, but it's a bit smarter, can read through the documents, find those words that refer to companies, and then check which one of those is Apple.
Yeah, exactly. Yeah, I think we've all tried using Control F in the past to look for certain things, but it also doesn't take into account like negative context, right? So let's say if you're looking for the word, like the fruit apple, but maybe they're saying, oh, this person didn't eat an apple, then maybe you don't want that information.
No, exactly. I think, this goes a bit further into more complex or more powerful models that are then able to, for example, understand, are you talking about the positive or the negative? So if you want only those documents that mention apples in a positive sense, so the presence of apples, it can really just look for those entities. Or if you want those that only mention the absence of apples. I mean, for apples and fruit, it doesn't make too much sense. This is, of course, much more relevant when you are talking about diseases. But apples is maybe I
think bringing it back to the medical audit, clinical audit example. Yeah, like let's say if 100 stroke patients came in and I was interested in who had a history of hypertension, so high blood pressure. There may be statements in which a clinician writes the patient does not have signs of high blood pressure, or they might even say, let's give some medication to this patient to prevent high blood pressure in the future. So there are many contexts in which we mention hypertension, but it doesn't necessarily mean the patient has hypertension at this current moment in time. So I think you're completely right. We need this model that understands the nuances of language in order to get valuable insights from the text.
No, exactly. And in fact, there are a couple of ways in which these problems can be solved. But maybe before we go into that, because it goes into a slightly more complicated topic, that's contextualization and meta-annotations and all of that. We want to focus still maybe a bit on the core task in NER. Should we cover like a bit of history? A bit of
history and also
model architecture.
And where is it most commonly used? Actually, I think that's before healthcare. Where was it used?
Yeah. Okay, so from the initially in the 90s or even before that, the models were rule-based. So NER, or the approach to that task, was rule-based. Rule-based means you are writing a rule that can be things like, if in a sentence I have the word MS dot, which would be like Mrs., I can be sure that after it appears a name.
Yes.
So basically, if you are writing a rule for detection of names, you would have, if I find MS, or if I find MR, or if I find one of those abbreviations, or DR for doctor or whatever, then I can be sure that after it, I cannot be sure. I assume that after it appears a name, maybe if it starts with a uppercase letter, and maybe if it's part of some vocabulary of a dictionary of names that I have. So if that happens, then I know this word is a name. So that was like a primitive version of NER, where people would go and write a lot of these rules. So another example that's maybe a bit simpler is for telephone numbers. You would have someone would go and say, if this number has like 7 digits, it starts with these 3 numbers, it ends with that, and a couple of more like patterns in which telephone numbers can appear. Then you would have a rule that is able to extract telephone numbers.
Yeah, the problem with rules is it's rigid, right? So like using the title example you used, if someone wanted to look for Mr., but then but maybe they were typing Mrs. and made a typo, so it's Mr. full stop S. Then if you wrote a rule for that, it'd probably just say, okay, this is Mr. Whereas it's actually Mrs. with a typo. So that's a limitation.
Yeah, and typos are one of the problems that rules cannot really solve easily. And another problem is whenever something new appears, you need to write more rules. So, for example, for the telephone numbers, the moment we stopped having fixed landlines and started having maybe mobile phone numbers or any other type of number that is now very different in format or how it is written and all of that, you would need to go and write many, many more rules. And what you need to know is at any point you're writing these rules, you need to know every single format in which a telephone number can appear. If you don't have that, doesn't work, or you will miss certain examples.
Yes. Okay, and then when did it upgrade to kind of the next level from rule-based?
So we switched the rule-based models for something called supervised training at the beginning of the 2000s. We were not writing manually rules, but at this point we were training a computer to automatically detect these named entities. Supervised training simply means we have a training data set. That means for, let's say, 100 phone numbers, we have manually detected 100 phone numbers.
Yes.
And now we use that to train AI models, so a computer basically, to automatically detect all phone numbers.
I see. So you're basically saying, look, computer, this is the 100 different phone numbers, and these are the variations. Just learn it. And if you see anything similar come up in the future, that's probably a phone number.
Exactly that. Yeah. So that was the beginnings of supervised learning. We still did not go into the real full-on machine learning and deep learning and all of that. So this is still relatively simple models that are looking at patterns in the text. So instead of me telling the model, oh, if you see dr dot, so doctor, or if you see mr dot, or if you see any one of those patterns, I would show it a lot of these patterns and let it learn from that.
Yeah.
So I will not write the rule explicitly. Yeah.